So side, angle, side, or side, side, side situation. I said that you would use it with non-right triangles, and it's really used when you have an opposite side, opposite angled pair that you know. Law of cosines you use if you know all three sides, or if you know a side angle side pair. Because if you know a side angle side pair, like let's say you knew C, this angle, and this, you wouldn't have the opposite angle, opposite side for law of sines. This is the law of cosines formula. Clearly, it's much more complex looking. It's not a direct proportion like the law of sines is. So if you have a choice between the two, you definitely want to go with the law of sines anytime you have that opposite angle, opposite side. But these are the situations where you're going to have to use the law of sines. So essentially, it starts almost looking like the Pythagorean theorem. C squared equals A squared plus B squared. But then there's this other part that's minus 2AB, and this A and B are always this side and this side that you use right there. And the angle times cosine C, the angle that they use here is the opposite angle of the side that's standing by itself over there. So it could, and the ABC part doesn't matter so much, you could have your A squared on this side, and then the other two sides are B squared and C squared, minus 2BC, and then cosine A. What's important is that this angle is opposite the side that stands alone. So this angle A is opposite the side that stands alone, and the third version would be if this was your B squared, what would these two be? A squared plus C squared minus 2AC cosine B, because that angle has to match that side. Okay? So, couple things. There's one real main common mistake that I'm going to warn you about when we get to it, and some of you will still make it anyway, but don't say I didn't tell you. There's one common mistake that I really have to warn you of because it happens all the time. So we'll get to it. So here's a triangle, and I'm always going to draw the triangle. A, B, C. Side B is 5. Side C is 4. Now, again here, they're not giving us angle A. They're giving us the cosine of A. So the cosine of A is 1/8. I don't want to label that 1/8 because that's not the angle measure. So I'm just going to kind of do something like that to show me that it's that angle. So do you see how I have a side given, information about the in-between angle given, and the other side? There's the side angle side that kind of points to law of cosines. Okay? Because this is the angle that we know about, we're really using this version, cosine A. So the A squared is going to stand by itself. This side squared equals what? 5 squared plus 4 squared. That's the B squared plus C squared. Minus 2 times 5 times 4. Cosine A. But I'm replacing the entire cosine A with 1/8. Correct? And because I'm solving for A, and A is pretty much already by itself, I'm just going to type this in all in one shot in my calculator. 5 squared plus 4 squared minus 2 times 5 times 4 times 1/8. Don't do any more thinking than you have to. You can type it in all at once, and you get 36. So A squared equals 36. You have to square root both sides. So A equals plus or minus 6, but we all know in geometry we wouldn't keep the negative because it's a side length. So A equals 6. If you just mentally know, you would never call a side length negative. You'd be done. Okay? So that one's not one that typically a common mistake gets made on, because what you're solving for is already by itself. You'll see when we're solving for an angle how people make mistakes. So go ahead on your own, set up this next one, triangle DEF, draw the picture, label the picture, and try to set it up. And we'll touch base once we're done with that. Brock, do you have the setup already? What'd you write? Cosine 120. Okay, you do. The last time we didn't, but I want you to make sure you understand the situation where you don't need to write the cosine and the situations where you do. This one, they told you the whole value of cosine A was 1/8. This one, they didn't tell us what cosine of F was. They told us just what angle F was. So we just replace F with 120 versus here we replace the entire cosine part with 1/8. Does that make sense? And then again, just type this in. And I got I got 37 too. Brock, you're probably in radians, because I don't believe you typed anything in wrong. Minus 2 times 3 times 4. Math, mode, radians, degrees. And now if I hit enter, you got 37. Okay, so F squared is 37. So then F in radical form would just be radical 37. Can we reduce that at all? No. Nothing goes into 37. I think 37 is prime. Okay. All right. Oh, they keep having me find. All right, jump to 4. Because 4, for the first time, we're going to be asked to find an angle. So sketch a picture. RE equals ED equals 5. So these are both 5. RE and ED are both 5. And RD is 8. So they're giving us a side, side, side. They're asking us to find angle E. So which side length stands alone on the other side of the equal sign? 8, right? Because that's the one across from the angle. So 8 squared equals 5 squared plus the other 5 squared minus 2 times 5 times 5 cosine E. So here's where people tend to make the mistake. They'll do 25 plus 25 minus 50. So I'll do 64 equals 25 plus 25 minus 50 times cosine E. And they'll take all 3 of these and they'll combine them, and that's where their mistake comes in. Why can't these 3 all be combined together? Correct. The 50 is a coefficient. These 2 can be combined. That cannot, right? So you can combine them if you want. You can subtract them over individually if you want. But we're on a mission to isolate E. So if you subtract that first 25 over and subtract that next 25 over, you have 14 equals negative 50 cosine of E. I don't add over the 50, right? For the same reason I didn't combine all 3 of those numbers. You have to divide over the negative 50 because it's a coefficient. So you divide over negative 50. And 14 divided by negative 50. Negative 0.28 equals the cosine of E. And what do I use on my calculator to solve for an angle? Inverse cosine of negative 0.28. So second cosine will give me inverse cosine of negative 0.28. And I'll get my answer to the nearest degree, which is, 106. Good? So the biggest mistake I'm telling you that kids do, including my advanced juniors right now, they'll do all of these all at once. And they would get 0, and then they'd be confused because, and you don't always get 0. Sometimes you actually get a number, and they'll divide over the wrong number. Carolina? To get from here to here, I used inverse cosine. So I'll show that. So you have to do inverse cosine of that negative 0.28, and that'll get E all by itself. So to get rid of cosine, you inverse cosine. So E equals 106 degrees. So do number 5 on your own. Just find the smallest angle. If I set up a triangle to be 2, 4, and 5, which one is the smallest angle? The bottom left, the bottom right, or the top? Bottom right, right? Smallest angles across from the smallest side. Do you remember that? Okay, so this is the angle that they're looking for. So call it whatever variable you want, but set up what you're going to do and find that angle. We'll talk about the nearest minute thing in a second. Mike, what's your setup look like? Okay. Tell me when you get there. Oh, you're stuck. So the setup should be 2 squared equals, because 2 squared is the one across from the angle we're looking for, equals 4 squared plus 5 squared minus 2 times 4 times 5 cosine whatever letter you want to use. Yes? There. So how you get comfortable and start solving this is up to all of you. I just subtract that over and subtract that over. So I subtract a 16 over and I subtract a 25 over. I get rid of those first, and that leaves me with negative 37. And then these coefficients all multiply by each other to give you negative 40. Good? Then you divide over your negative 40, which is where I stopped. And cosine A equals 0.925. And then this is where, Carolina, what do I do to solve here? Inverse of cosine. Good. Will give me angle A. So inverse cosine of 0.925. So that's angle A equals 22.33164501. Do we all get that? Yes? Raise your hand if you didn't get that. Let me see. You know what you did? Okay. No. It's that fraction of 60. It's like 33%-ish of 60. Does that make sense? So like when you have 30 minutes out of an hour, that actually changes to the decimal 0.5, right? So it's with minutes, because they're out of 60, it's not the same. So we're just now going to address, that's it to the nearest whatever decimal I went out to. But to the nearest minute, that's 22 degrees. And then this fraction of 60 minutes. That 0.33 of 60 minutes will tell you the right number of minutes. So if I just take that, I'm just going to subtract 22 off of that to get my exact number. That's the fraction of, in math, means what operation? Anytime you take a percentage of something, what operation is that? Of means multiply of 60. So that fraction of 60 leaves you, what's that to the nearest minute? 20 minutes. Which makes sense because 0.33 is like a third, right? And a third of a minute would be, or a third of a degree would be 20 minutes. Follow? Okay. What do we got? Just do 3 on your own quickly. See if we can go start to finish. Subtract 3 numbers between 1 and 20. All right. Moment of truth. I did. Brock was 1. No, actually, Ellie was going to be my initial 1, and then you just ended up being 5. So you said 1, 5, and 14. I can rig it and start with anybody, but then the other 2 have to. All right. All right. I don't know whose this is, but RTS, R is 11, S is 12, T is 42, so we know how to label a triangle. That's good. So T is what we're looking for. It's all by itself. 12 squared plus 11 squared minus 2 times 12 times 11 times the cosine of 42 degrees. Perfect. Raise your hand if you got T equals 8.3, so I don't have to check his math. Good. So he just typed all that into his calculator, got an answer, square root of both sides. Pass that back to him. All right. Here we have RST. R is 11. S is 12. T is 42. Ooh. So we have the T squared because that stands by itself. That's correct. It should be these 2 squared added together. So this person has 5 squared plus 12 squared. Should be 11 squared, 11, and then the cosine of 42. You know why? You were probably using another example, like to guide you, and you pulled the number from that one. That happens all the time. And 8.3. That was correct, we said, right? Good? Okay. So, can you pass it back to Ellie, please? Your homework is coming around. It's just 10 questions again, just like last night. Have a wonderful weekend. Sort of. Like a weekend.